Hello students, I am Dr. Sanjeev Punia. In computer graphics, last lecture we discussed about 2D transformations and window to viewport transformation. Now we are doing the second unit of computer graphics, and in in this we discuss different parts of the 2D transformations. First, we discuss that what is geometric transformation and what is coordinate transformation. Geometric transformation is a transformation where the object is remain fixed and the background of the object is going to be changed, whereas in coordinate transformation the background of the object remains same and the coordinate of the object is going to be changed. Then we discuss about the matrix representation, that how we can represent the object in the form of a matrix. Then we discuss about the basic transformations as translation, scaling, rotation, reflection, and shearing. In the last one, we discuss about the composite transformations. This was about the 2D transformation. Same thing, near about same things we are going to apply in the 3D transformation also. So when we will discuss about the 3D transformation, then first of all we will discuss that how we can represent an object in matrix form. When we have a 3D object, then how we can represent that object in matrix form. Then we will implement the same transformation techniques those we discuss in 2D, that is translation, scaling, rotation, reflection, and shearing. And in the last topic, we will discuss about the composite transformations. So this is the complete overview of 3D transformations. So today we will discuss that what is 3D transformation, the matrix representation of that, and in transformation we will discuss about the translation only. Till here we will discuss today. If we have some time, then we will discuss about the scaling also, and the example based on translation. So let's start from the 3D transformation. As we discussed earlier, that when we have a object in 2D, suppose this is a object in 2D, then it has x and y coordinate. It has two coordinate x and y. It means if this is the origin 0 and 0, this is the origin 0 and 0, then distance from origin on x-axis is x, and distance of this object from origin on y-axis is y. Means we are going to represent each and every object by using two coordinates x and y, means in x direction and y direction. In 3D transformation, we represent an object in three dimensions. These are two dimensions x and y, plus we add one more dimension, and that is called z dimension. Means when we represent an object using three coordinates. For an example, this is x, y, and x, y, and z. If an object is going to be represented using these three coordinates, then that is a 3D object, or a 3D object is going to represent using these type of coordinates in which there are the value of x-axis, y-axis and z-axis. We will discuss about the z-axis within a moment. Now, when we want to discuss about the 3D transformation, then we discuss about the transformations. Means we know that what's the transformations. Transformations are the different techniques, procedures by which we can change the location, we can change the shape of an object. So we discuss this in 2D. The difference is only 3D, and I told you the difference in 2D and 3D is of the coordinate system, means of the directions, or on the axis, x, y, z axis. So here we will discuss about the 3D transformation, and that is the extension of 2D transformations. Means whatever we discuss in 2D transformations using two coordinates x and y, now we will implement the same things using three coordinates, using three coordinate x, y and z. So 3D transformation is the extension of 2D transformation. In 2D, we have to represent the object using two coordinates, whereas in 3D, 3D we have to represent an object using the three coordinates, that is on x-axis, y-axis and z-axis. So these are three coordinates. Now, when we have to represent the three coordinates, this is the thing that we discuss in 2D, means this is x-axis, this is y-axis, this is y-axis. Now, these two axes are perpendicular to each other, means the angle between x and y axis is 90 degree. So third axis also have an angle of 90 degree with this existing x and y axis. So if I pass a axis from top to bottom, from top to bottom, if we are considering here the corner of a room, the corner of a room from the bottom, then in one direction, this is the corner of a room, and this is the height of room. Then in one direction, this is x-axis. On another direction that is perpendicular to this is y direction or y-axis, and third one that is perpendicular to x as well as perpendicular to y. This is called third axis, that is z-axis. So in 3D we have to access three dimensional, that is x, y and z plane. So now about the z axis, we can consider two things. We can consider number one corner of the bottom of a room, one corner of the bottom of a room, and like this. And second one, we can consider the roof of a room, the corner of the roof of a room. Then in that case, this is x direction, and the perpendicular to this is y direction. So third direction is called z direction. So from this it is clear that z direction or z axis is either going to upper side or it's going to lower side, as we discussed in two dimensional, that this is x axis, this is y axis, this is y axis, this is origin, this is origin means point O, where the value of point O is 0 and 0. We discuss about this, that when in the right hand side of the origin, in the right hand side of the origin, the value of x is positive, and in the left side of the origin the value of x is negative, means this is minus x. Same in the case of y axis also, when we are going upward, when we are going in the not upward, in the another direction that is perpendicular to x, so the value over y is plus y, and in the reverse direction, in the reverse direction the value of y is negative, negative y, negative y. So here when we are saying about the third axis, the suppose this is the third axis, this is starting from O to upper side means to the top, then this is called positive z, this is called positive z, means the values in this direction is positive, and when it is going in the opposite side, when it is going in the opposite side, then its value is minus z. So this is the reason that we want to discuss about the corner of a room from the bottom side as well as from the roof side, because when we are considering the height from the bottom of the room, then the height or the arrow or the axis that is perpendicular to x and y, that is positive. And when we are discussing the point on the roof, then below axis, then below z axis is negative. So here when we have to find out the value of z, then there are two system orientations where we can find out the value of z. First one is right handed and second one is left handed. We have to find out the value of z, that it is positive or negative, by using the right hand thumb or left hand thumb. This is called thumb rule. This is called thumb rule. So in right handed, we have to put our third axis by assuming that third axis is on thumb. This is one axis. Suppose this is one finger, this is another finger, second finger. So we can put these two fingers, we can put these two fingers in a single, in a same plane. Then when the thumb either indicates in the upper direction or in the lower direction. If the right hand thumb, if the right hand thumb goes to positive direction, means to upside, then it is positive, means the value of z is positive. And when we are using the left hand thumb, then in that case, in the direction of the thumb, the value of z is negative. So from here we discuss that the z axis is perpendicular to x and y. In one direction it's positive and in another direction it's negative, like x and y axis. Now we will try to understand these axes from this cube. This is a cube. We first, I want to tell you about the axis. This is the y-axis. This is the x-axis, and a axis that is perpendicular to this. You can understand it from here that this z-axis is perpendicular to this. This is the z-axis. In that, in 2D, we were discussing about x and y only, means these were on a single plane. On a single plane, you can consider that this is the floor of the room, then these two are in the same plane. But when we are considering the third point, the third direction, then that is in the vertical of x and y, means in the third direction, that is a plane perpendicular to x and y. So suppose the value of x-axis, the value of x-axis is x, and on y-axis this is y. Same on z-axis, the value of this cube is z. Means we have a cube, where one side of the cube is x, another side of the cube is y, and third side means height of the cube is z. You can understand it by one way also. Suppose we have a box, suppose we have an box, then length of the box is called, or is maybe on the x-axis, length is on the x-axis, its breadth is on the y-axis, and z is on the height. So these three are perpendicular to each other. When this is a cube, so the length of this length will be equals to this length, this length will be equals to this length, as well as this length also, as well as this length also, means for the sides, all four sides of the cube are equal. And when we are considering this x, so this one, this one, this length, and this length are x, are x. And in y, in z direction, this one means height of the cube over here is same. So on these points height is same. So suppose I want to find out this point. I want to find out this point, the value of this point. Then this is the value of x-axis. It is x distance away. This is x distance away from the origin, but the value on y-axis is 0 and the value on the z-axis is also 0. This is the value on y. When we are considering this value, same value on the y-axis, then the value of x is 0. The value of x is 0. Only it has the value on y-axis, that is y, and value of z is also 0. When we want to see the value of this point on z-axis, then it is x is 0, y is 0, and z has the length that is equals to the cube on z-axis. So this was about the three corners. This was about the three corners. Now we will try to find out the values of another corners also. So when we want to find out the value of this corner, then in x direction, this is x distance away. This is x distance away from the origin or from the y-axis. The distance from the origin is or it is y distance away from the x-axis and on the same plane, means the value of z is 0. Value of z is 0. When I want to find out the value of this, then it will be x in x direction. This is x. On y direction, this is 0, and on z direction, this is z. Same, we can find out the values of all the points. Now I will discuss the values at the point A, B, A, this is B, C, this is C, and D. So this is D. So we will try to find out the values at point A, B, C and D. Now we can understand from here that on x-axis the distance is x, the distance is x, so the distance from the y-axis to this point is x, distance of this point B point from the y-axis is y, and it lies on the plane x and y, means the value of z is 0. Over here, when we want to find out the value of a, then in that case this point is x distance away on the x-axis, y distance away on the y-axis, y distance away on the y-axis, and z distance away from the z-axis or yz plane. So by using these way we can find out the values of this. I will try to make it more clear by drawing another example, because first of all we should know that how we can find out the values of different points. So now I will try to draw this by using an object in different way. Suppose this is the coordinate system. You can understand this in a way that, let me change the color of these. The color of this is red. The color of this is yellow. So you can try to understand that when this is a corner of a room, this is the corner of a room, then in this represent one length, this represent second length of the corner, and it represent the height of the room. So this is one direction, this is another direction, and this is height, and all these are perpendicular. All these are perpendicular. You can, this and this are perpendicular. This is perpendicular to this axis and perpendicular to this axis also. So all these three are parallel to each other. Now if I want to draw an object, suppose the object is, this is x direction, this is y direction, y coordinate, and this is z coordinate. Then in that case, on x-axis the length of my object is, for an example 5. On y direction the length of my object is, for an example 6, and on z axis length of my object is, for an example 3. For an example 3. So the object will be look like this is, this will be parallel to y axis. Let me change. Let me take the straight line. It will be more clear from the straight line. So this is the another side. This is the another side on y-axis, and this is the parallel of x-axis, means parallel side, or x distance. So this we are discussing the floor of the room. So on one axis this is 5, on another axis this is 6. So when we want to consider this, then this point will be on x-axis, this point is 5, on x-axis this is 5, on y-axis this is 6, and as it lies on the floor, so the value of z is 0. I hope now it will be clear to you that how we can find the values of different coordinates in three dimensional. This was about the horizontal plane. Now I want to discuss about the vertical plane, plane between x and z. Okay, first we will try to discuss about the y and z. So this is z. So this will be another height of 3 on z axis. This will be another height, and this is y distance away. So you can understand it by that this is one wall. This is one wall of the room. Then the distance from the origin on this wall on y is 6. So the distance from the x-axis is 0. So this will be 0. The distance on y will be 6, and distance on z will be 0. When we will try to find out the values of this corner, so the value of x is 0, the value of y is 6, and it's 2, sorry, 3, it's 3 unit away from the origin. So this is 063. This is 063. If I want to draw the same on x plane, so this is the x plane, this is one line, this will be the another line of the object, this will be another line of the object, and object will look like this, from this side. So the coordinates of this point, the coordinate of this point is, this is 5 unit away, 5 unit away from the origin on x-axis. On y-axis this is 0, and on z-axis this is 3 unit away from the origin, so now we discuss these two on y-axis, on x-axis. If I want to draw now complete object, then in that case I have to draw the parallel line on z-axis also. On z-axis, so this will be like this, This point will be over here, and this will be like this. So this is our object, this is our object. The coordinate of this point will be, this is x distance away from the origin on x-axis, this is 5 unit away on x-axis, this is 6 unit away on y-axis, and 3 unit away 3 unit away on the z-axis. So the coordinate of this is 3. So the complete coordinate of this point is 5, 6, 3. So in this way, we can find out the coordinates of an object using x, y, and z direction. Now we will see that what's the transformation. Transformation is a process by which we modify the object. Either suppose this is an object, then either we are modifying the size, or we are modifying the coordinate system. Means when we are moving, when we are performing any action on the object, and that is going to change either the shape or the location of that object, then that is called the transformation. Transformations are basically 5 types. First one is translation, means to translate, to change the location of an object from one place to another place. This is translation. Scaling means to enhance or decrease the size, to enhance or diminish the size of the object. In this, the shape of the object is same, but in scaling, shape of the object is going to be changed. In rotation, this is rotation about the plane, about the x, y, z we will discuss, but in this the size of the object remains same. Reflection, the size of the object is same. This is like we are seeing our image on the mirror, means this is the reflect of the original object. And in shearing, the shape of the object is going to be changed. For an example, we are putting a pressure on one side of the object, then the shape of this is going to be changed like this one. And here we are discussing about the 3D, about the 3 dimensional. So today we will discuss about the translation and one example based on the translation. So let's start from the translation. So 3D translation. This is a process. This is a process by which we can move an object from one position to another position. This is x-axis, this is y-axis, and this is z-axis. Suppose an object O is over here, then coordinates of that object, the original coordinate of that object is x old, or I can write x1 y1 z1, x1 y1 z1, Here I wrote it f old, the distance of object on x-axis, the distance of object on y-axis, and the distance of object on z-axis. So coordinate of this object O is x old, y old, and z old. When I move this object from O to O dash, from O to O dash, now the shape of the object will be same, shape of the object will be same as I told you, the position is going to be changed from x old, y old, z old to x new, y new, and z new. So in this case we have to find out the values of x, y, and z coordinate. There are some values, those will be given to us, that how much we have to change the location in x-axis, y-axis, or z-axis. We will see this in the next slide. So as I told you in the last slide, that suppose we have an object O where the coordinates are x, y, z old. Here we have an object where the coordinates are x, y, z, and old. And after performing the translation on object O, the new coordinates are x new, y new, and z new. The translation vector or shift vector means in which direction on x-axis how much we have to transfer, or how much we have to shift the object, on y direction how much we have to shift, and on z direction how much we have to shift. So Tx, here Tx defines the distance, Tx defines the distance the x old coordinate has to be moved. Tx is the distance that shows that on x axis how much distance it has been moved. So it moved from this one to this one on x-axis. So this is Tx. This object moves on y-axis from here to here, from here to here. So this is on y-axis, and this is on z-axis, that how much it's move on the z-axis means how the height is going to be changed. So these are the three things, that is Tx, Ty, and Tz. Based on that we have to find out the values of new coordinates. So in this, the new coordinates are, we have to add the translation coordinate. We have to add the translation coordinates, means tx to the old x, ty means translation in y direction to the y old, and translation in z direction to z coordinate in old. So this will be, x new will be x old, x coordinate new value will be the value of x coordinate old plus tx means translations towards x axis. Same translations on y axis and z axis. When we want to represent this in the matrix form, then it should be it should be yes, it should be plus. It's by mistake, it should be plus. So as I told you that we can represent the coordinates either in the row matrix or in the column matrix So here we are representing the matrix in form of rows. In form of rows means x coordinate, y coordinate and z coordinate. This one is going to be added to make the symmetric, to make the symmetry, as we discussed in the 2D dimensional also, to make the matrix homogeneous. So we have to add this. So we will multiply, when we will try to find out the value of this, so this is 1 multiplied by x old, 1 multiplied by x old. So this is x old, this will be 0, this and this will be 0, this and this will be 0, and tx multiplied by 1 is tx, so this is tx. Same we can find for the y new and z new also. So y new will be y0 y old plus ty. So in this fashion we can find out the values of new coordinate after the translation. Now I think yes, this has been finished. Now we will see an example based on translation. So a 3D object is given to us whose points are, suppose this is our 3D object. The points of these are is any point. Any point means, as we discussed, that this has I will show you. This is an object. This is an object. When we are drawing this object, then it has 8 corners. It has 8 corners. So this is 1 corner, 2, 3, 4. These are 4 on this side and 4 will be on the opposite side. So this will be 4 plus 4. So you can think, sir, here should be 8 points. But it's not necessary that in question they will ask about the translation on each and every point, because in exam they want to see that you know the concept of translation or not. So generally they ask about 3 or 4 points, not more than that. But if you know the concept, then you can find out all the coordinates after the translation. So these are the basic coordinates, means these are the old values, means old coordinates are A is 030, A is 030, B is 332, B is 332, C is 302, and D is 000. That's the origin. These 4 points are given to us whose coordinates are 031, 332, 300, and 000. Now Apply the translation with the distance 1 unit towards x-axis. So tx will is 1. Translation on x-axis is 1 unit, 1 towards y-axis. So ty translation on y-axis is also 1, whereas 2 unit towards z. So tz equals to 2. tz equals to 2. Now we have the values of old coordinate. We know the values of tx, ty, tz, tx, ty, tz. We discussed on the last slide that we called it translation vector also. Now we have to apply the formula that we discussed in the last slide, that is to addition of tx in the old x, ty on the old y, and tz on the old z. So new value on the based on these equations. When we want to find out the new value of coordinate a, the value of coordinate a is 031. You can see from here that the coordinate of a is 031, and we have to perform this is x old, first one is x old, this is y old, and this is z old for point A, and same in the point B, C, and D also. When we have to find out the new coordinate of point A, then we will try to find out the coordinate for this first, then this, and then for the D. Means we will try to find out the coordinates of each and every point individually. So in this, these are given. Now we will try to find out the value of coordinate A. This is 031. Original values were 031, and we have to make the translation in x-axis 1, y-axis 1, and z-axis 2. So the original values are 0, this is 0, 3, and 1 are the original values of x old, x, y old, and z old. And we have to perform 1 unit translation in x-axis, 1 unit translation on y-axis, and 2 unit translation on z-axis. So new values are 0 plus 1, that is 0, 3 plus 1, that is 4, and 1 plus 2, that is 3. So new points corresponding to point A are 1, 4, 3. 1, 4, 3. So this is the way by which we can find out the coordinates of transformed object. So the coordinates of point B, or the original coordinates of point B was 332. So we are performing the same. That is, these are original coordinates 332, and the translation in x direction 1, y direction 1, z direction 1. So this is 3 plus 1 is 4, 3 plus 1 is 4, and 2 plus 2 is 4. So next coordinate means new coordinate of B is 4, 4 and 4. Same way we can find out the new coordinate of C also. So this is 3, 0, 0 and we have to change 1, 1, 2 in each direction. So this will be 4, 1 and 2. So final coordinates are 4, 1, 2. In D also, when we are trying to find out the coordinates of D, then earlier coordinates was origin. This is the old coordinate or original coordinate. We have to perform the transformation on x-axis 1, on y-axis 1 and on z-axis 2. So this is 1 plus, so 0 plus 1 is 1, 0 plus 1 is 1 and 0 plus 2 is 2. So these are the new coordinates corresponding to point D, corresponding to point D. Now we wrote these new topics, these new coordinates of these points. So earlier the value of D was 0, 0, 0. You can see from the last slide, from the original values here, this was 000 and A031, B332, C300, D003 transactions or transformation translation in x direction, that is tx equals to 1, ty equals to 1, tz equals to 2. So by applying the translation on A, B, C and D, all the points, we find new coordinates of A, that is 143, B 444, C 412, D 112. So this is the way by which we can find out the translation on an object. So today we discuss that how we can represent a 3D object and we discuss about the translation also. Now in next class we will discuss about the scaling, 3D scaling. So thank you. Thanks a lot for this class.